Morning. Today we are going to discuss the topic ion exchange process. Ion exchange method is used to remove hardness causing cations and anions from a hard water. That's why this process is known as demineralization or deionization process.
It is a long chain polymer with containing replaceable cation H plus ions or OH minus ions. And that type of resins are known as ion exchange resin. By using that type of resins, we can reduce the hardness of a particular water sample, or we can remove a mineral present in a water sample, and that is known as demineralization or water softening method by using ion exchange resins, and that is known as ion exchange process. In this, demineralization is achieved by using ion exchange resin. Then, there are two types of ion exchange resin: cation exchange resin and anion exchange resin. The cation exchange resins can be generally denoted by RH plus, where H plus stands for the replaceable hydrogen ion, H plus ion, and R is represent the long polymeric chain with the acidic functional groups like COOH, CO, SO3, etc. And anion exchange resin is generally represented R plus, OH minus, and it's containing replaceable OH minus ion, and R represent the basic long chain polymeric resin containing basic functional group. This is an example for then. Next is cation exchange resin. The resin containing acidic functional group are capable to exchange their H plus ion with other cations, and that type of resins are known as cation exchange resin. And one example for particular example is styrene divinyl benzene copolymer, which on sulfonation or carboxylation become followed by acidification is capable to exchange their hydrogen ion and with water cations present in water, and that type of resins are known as cation exchange resin. These are the basic acidic functional group SO3H, COH or OH present in uh, cation exchange resin. This is generally represented by RCOOH or SO3H, or the detailed structure is like this with a styrene divinyl benzene, or you can generally represent a polymeric head. It's a long chain polymer containing SO3 minus, then H plus. This H plus is exchangeable H plus. This is capable to exchange this H plus with the cations present in hard water. And this type of polymers are known as cation exchange resin. Next, another type of resin is anion exchange resin, and it is generally represented by R plus OH minus. That is, resins containing basic functional group are capable to exchange their anions or OH minus ions with the other anions present in hard water, and that type of resins are known as anion exchange resin. Example, styrene divinyl benzene, which contain amino quaternary ammonium compound with the replace followed by dilute NaOH, and it is capable to exchange their OH minus ion with the anions, and that type of and it is known as anion exchange resin, and it is generally represented RNH3 plus OH minus, or a polymer long chain polymer CH2 NCH3 thrice plus. It is the basic functional group with OH minus ion, exchangeable OH minus ion, and that type of that is an example for a anion exchange resin. I come to the details of cation exchange process or ion exchange process. The water or hard water that is first passed through a cation exchange resin. In this step, that is the replace H plus is a exchange of H plus with the cations present in hard water takes place, and remaining water sample is passed through anion exchange resin. In this step, the remaining anions is exchanged with OH minus ion. Then we get water that is free from hardness causing cations and anions, and that process is known as cation exchange resin. Then there is one question: why we are passing the hard water first through cation exchange, or why we are follow this particular sequence of first cation exchange resin, then anion exchange resin. The reason is that why what happened? The first we are passing the cation exchange hard water to cation exchange resin, the remaining water containing anions and H plus ion. Then if you are first pass through anion exchange resin, when what happened? The water containing cations and OH minus ion. The water is acidic, is basic in nature. So basic the corrosion, there is a chance of corrosion is more in alkaline condition. So that's why we are passing the hard water first through cation exchange resin, then to anion exchange resin. That's the reason. And the detailed process, detailed schematics for the cation exchange resin and anion exchange resin is first the water is passed through cation exchange resin and it is connected to a acid for there is a function of this one for the for to regenerate the cation exchange exchanger. Then it is passed through anion exchange resin. It is connected to a base alkali like NaOH, dilute NaOH. Here we take dilute HCl or dilute H2SO4 to wash the cation exhausted cation exchanger. Here alkali dilute NaOH to wash the exhausted anion exchange. Detailed what happened if a hard water containing these are the mainly hardness causing cations calcium and magnesium ion. First it is passed through a cation exchange resin. This one is the cation exchange resin RCOOH. Then what happened? This one is CaCl2 stands for the hard water containing calcium chloride. This one MgSO4, another hardness causing cations present in hard water. Then this cations, calcium, here cations, calcium is replaced with the H plus and the react RCO twice Ca plus 2H plus 2Cl. The remaining water containing H plus and anions in present in hard water. And here RCOH plus MgSO4 gives RCO twice Mg plus 2H plus L. Remaining water containing H plus and the remaining hardness causing anion. And remaining H plus and hardness causing anions are passed through next compartment, that is anion exchange resin. Here what happened? The active anion exchange resin containing OH minus ion that is replaced with the or exchanged with the anions present in hard water. In that way, the complete removal of all harness causing cations and anions takes place in water. We get a water free from harness causing cations and anions. The detailed schematic diagram for a cation exchange resin and anion exchange resin process. First pass through a active cation exchange, the block diagram. The active cation exchange means the resin which is containing active H plus ion or H plus that is ready to exchange their H plus with the cations. And what happened? First pass through active cation exchange resin. Then what happened? All the cations are replaced with the H plus present in the water. That is Ca2 plus, not Ca2 minus, Ca2 plus. Then remaining water, that is H plus and anion. Cl minus simply represent the all the anions present in hard water pass through active cation exchange resin. In active anion exchange resin, all the anions present in hard water that is replaced with the OH minus ion present in active cation exchange resin. And this one and remaining resin is like Nr3 plus Cl minus. Rnr3 plus Cl minus. This one is known as exhausted anion exchanger or this one is known as exhausted cation exchanger. What do you mean by exhausted? Is not able to exchange their cation because it is already replaced with the H plus present in hard water. Then exhausted cation, if we wash with the dilute HCl or dilute H2SO4, we can regenerate this exhausted cation exchange process. Or if you are washing with dilute NaOH, we can regenerate this exhausted anion exchange process. That is one of the advantage of this cation exchange process. And this is the reaction for RN3 NCH3 thrice plus OH minus plus Cl minus gives RnCH3 thrice plus Cl minus plus OH minus. Reaction for active anion exchange resin. We get water free from all the ions, harness causing ion is, and this method is known as water softening method. One of the advantage of this method is the process can be used to soften highly acidic or alkaline waters. And another main advantage is the resins can be regenerated. It's a main advantage, or it produces the water of very low hardness. It's for we can use this type of water in high pressure boilers, because if a hardness is more, the boiler corrosion of boiler is, well, there's a chance of corrosion. And the main one of disadvantage is equipment is costly and more expensive for chemicals are needed, and water turbidity must be low. That's a two limitation for this ion exchange method.